Let's look at how to draw Lewis structures in a short way. And group 8 has neon, it has octet complete, so no bonds needed. And then on top of that, helium has a duet and it doesn't react either. Now the other ones, the in red is the group or number of valence electrons actually. So lithium has 1, beryllium 2, boron 3, carbon 4, nitrogen 5, and oxygen 6, and fluorine should have 7. So now we can look at, the group numbers 1 to 8, the number of valence electrons in it. So that's the important thing to write couple of times and know. Now we can look how many bonds we need in order to reach the octet, because filling the octet is the requirement to be stable for an element, right, or atom. Now lithium needs 1 bond basically, beryllium needs 2 bonds, boron needs 3, carbon 4 bonds needed, and nitrogen missing only 3, so that's a 3 bond, oxygen 2, fluorine 1, and noble gases don't need any bonds. Now we can show this way too. Hydrogen needs 1 bond, beryllium needs 2 bonds because you have 2 electrons only, and the boron has 3, so you can make only 3 bonds. They are beryllium and boron are electron deficient, right? Now carbon needs 4 bonds, clear. Nitrogen needs 3 bonds, and oxygen in that case needs only 2 bonds. And you have 2 lone pairs on the oxygen. Fluorine has 3 lone pairs, and then 1 bond is needed. So that's how the first thing we should notice about the bonds. So we notice the families or the group numbers, we notice the valence electrons, the outermost electrons, and then we notice how many bonds needed, right? So we will look at what are the more important things. When carbon needs 4 bonds means actually it can be like this way. So two double bond and 2 singles, or triple bond and a single bond. That's a possibility. Now also carbon can have a plus and 3 bonds and a minus and 3 bonds. So those are the possibilities for carbon. So it's good to know and draw it first. For the nitrogen, you can have 3 bonds and a lone pair. That is possible as above, right? And you can put another bond on nitrogen. So if you put that one, actually move the bond to the nitrogen, so you have 2 lone pairs on the nitrogen showing a negative sign, so negative charge. And also just know nitrogen can have 4 bonds, because if you take 2 other bonds as I put the arrow, so you get a positive on the nitrogen, right? So 4 bonds and a plus, 2 bonds and a negative, and no charge on the 3 bonds, right? Oxygen, 2 bonds and no charge, but 2 lone pairs. Now you can open that bond into a lone pair, so you get 3 lone pairs and single bond, so that has a negative sign. Now if you put 2 bonds to this one, oxygen will get 3 bonds and a lone pair and a positive, right? Oxygen will not make 4 bonds. Now fluorine makes only 1 bond, so there is nothing else happening. So hydrogen and fluorine, actually fluorine, chlorine, bromine, iodine, all of them, it's very simple. It's just 1 bond most of the time, right? Once we draw a couple of examples, because it's memorizing how each atom makes bonds is an easy way. So CH4, it's pretty straightforward. Carbon needs 4 bonds. You put the 4 bonds, and 90 degrees is fine when you draw the Lewis structures, right? And then C2, H5, H6 actually. So let's put this on 6 here. And first thing, connect carbon to carbon. So that's a must. Now we know each carbon needs 3 bonds more, right? That's how you satisfy the 4 bonds for each carbon. Then put the hydrogens, right? So that's similar to the top methane, and ethane is like that, right? So CH is 6, yeah. Now CH3OH, again similarly, you start with the CH3 completed, C with 3 hydrogens and oxygen along the line, and then 2 lone pairs on the oxygen and hydrogen should be connected, right? Now, if you have C2H6O, let's see how do we change. 2 carbons are connected, oxygen also in line connected. It has to be because hydrogen only terminals. Now 3 carbon hydrogen bonds, hydrogens connected to the corner carbon, and then you have 2 left. You're going to stick those ones, and oxygen needs 2 bonds, 2 lone pairs, all satisfied, right? So it's kind of, you have to draw a couple of times, then you will be familiar with that. Now, so let's see here, this example given is CH5N. So it's kind of weird formula, but let's see what happens. So carbon and nitrogen connected, right? And then there's a lot of hydrogens. Let's put 3 hydrogens as usual we have been doing. Now we have 2 more hydrogens. We can put it to the nitrogen. Then nitrogen has a lone pair, right? So that's the shorter way to do it. Now if I'm given CH3COOH, and then again carbon oxygen connected, let's say, and then 1 carbon can have 3 hydrogens. That's a typical way we did it. And O gets H. That's also now missing 2 bonds, right? And also we have an extra oxygen. So when put the oxygen, and we know we need another bond, so we can put that one. So that's how you get the double bond row. And then also you need actually 2 lone pairs, right? So now that's how you make the oxygen double bond, right? So you sort of satisfy everything else, come back and put the double bond after counting the bonds, right? Now CH3ONA, again carbon and oxygen should be connected, and hydrogens are typically, we put it like that, and then we have to see what's going on. So when you have sodium, lithium, potassium, make sure they are positive and the other side gets negative. That's a typical way. Now negative means oxygen needs 1 bond and 3 lone pairs, and sodium plus the counter ion can sit by the side, right? So that's a way to think about when you have sodium, potassium, lithium in a compound. So let's look at this one, C2H3N. Again carbon nitrogen connected first, and we can also make the terminal CH3. Normally we get it. If we make a mistake, we fix it, right? So then we see the center carbon needs 4 bonds. No, this is not the place actually. Yes. So because terminal carbon is fine. Carbon and nitrogen in between, you need 3 more bonds. So we put there. So in red, actually pi bonds. It's not really, you don't have to recognize in a Lewis structure, right? Just for further later, I just put it there. Okay. Now the summary again, you can take a look at. So you start with group numbers, right? Groups are important to know, and 1, 2, 3, 4, 5 in order, and also you have to know 8th is not reacting because it has the full shell. Then we pay attention to the valence electrons, and also by drawing, and then pay attention to the bonds, how many bonds we need for each atom in a compound, and then the variations. So carbon has 4 variations, nitrogen has 3 variations, oxygen has 3 variations, fluorine has 1 variation, and then hydrogen has 1 method, right? And like I said, fluorine means chlorine, bromine, iodine also follow the same suit. Now, just to remind you again, it's better to sort of know right away. The carbon can have 4 bonds, double bond, triple bond, and negative or positive. You see, it's one shot, you know how many things carbon can do. The nitrogen also the same thing. Nitrogen can have 3 bonds and a lone pair, no charge. Then nitrogen can have 2 bonds and negative charge, 2 lone pairs. And nitrogen can have 4 bonds and a positive. So that's the only way nitrogen can stay in a compound, right? Now oxygen, now nitrogen and phosphorus both behave the same way, almost. And oxygen and sulfur selenium will behave the same way. So double bond O, 2 lone pairs, no charge. Single bond O, 3 lone pairs negative. And 3 bonds oxygen positive.